Hi, welcome back. This is lesson 1.3 of chapter 1, and we are going to continue on and review the concepts of evaluating algebraic expressions and translating word phrases into algebraic expressions. Okay, so we're going to be making some expressions and we're going to be plugging numbers in and figuring out their value. That's what evaluate means. So here we go. Let's define a couple key terms. We have to know what the terms mean so we understand what's being asked of us. All right? So a variable. A variable is a symbol. It's usually a letter. It could be X, Y, Z. It can be any letter in the alphabet. But it's always used to represent an unknown number. An unknown number. You just use a variable when you're looking to find something. You use this variable. Okay? An algebraic expression is just a string of numbers and variables. They're joined together by grouping symbols and or operations. So we could have 3, let me change my pen. We could have 3 times x plus 5. That would be an algebraic expression. 3x squared, that would be an algebraic expression. 2y, that would be an algebraic expression. Remember that whenever a number and a letter are butted up against each other, it's implied multiplication. When you are asked to evaluate, an expression, that means you plug in the values that they give you, and you use the order of operations to reach or to calculate a single value. I've referred to it as plug and chug. It's kind of a academic term for shortcut term we use in the world of mathematics. Plug and chug. All right, here we go. Okay, a couple things to be careful of. You might want to star this slide. Okay, unless parentheses are used. So, unless parentheses are used, it means if no parentheses are there, the exponent refers only to or is applied to. This refers as applied. Applied only to the variable or number immediately. Immediately. Highlight that word. Immediately. Okay, when I do that, immediately before it. Okay? When you're evaluating, be careful handling terms like this example 3m squared. Notice the difference if parentheses occur. All right? We have 3m squared. That's the same as 3 times m squared, which is equal to 3 times m times m. You see there's only one 3, only a single 3 in the mix. But watch what happens as soon as we put parentheses around it. This is 3m, parenthesis, 3m squared. That says we're going to take 3m and we're going to multiply it by 3m. All right? So that means I have a 3 and a 3 and 2 m's. Notice in this case the 3 gets squared too, and this actually equals 9m squared. Okay, so it's crucial that you know how to work when you have parentheses. Okay, this exponent gets applied to everything inside the parenthesis. Okay, parentheses are also crucial when you're plugging in and evaluating with a negative value. If you're plugging in a negative value, put parentheses around it every time, even if none are in the original problem. Okay? Let's evaluate the following expressions. Okay? We're told that x equals 5 and y equals 3. So, wherever there's an x, we're going to plug in a 5 and then use the order of operations. Okay? And wherever there's a y, we're going to plug in a 3. So I have 2 times 5 plus 7 times 3. Now my order of operations says do my multiplication before my addition. So I have 10 plus 21. And now I can apply my addition, and I get 31. And there's my final answer. It's evaluated down to a single number. All right, on example B, we're going to start with the same way. We're going to plug in our numbers, and then we're going to simplify the top separately from simplifying the bottom, and then do our division at the very end. All right, so I have 9 times 5 minus 8 times 3. On my bottom, I have 2 times 5 minus 3. Now, focus on the top. Do the top first. All right, 9, we have to do multiplication first. So we have 9 times 5 is 45 minus 24. Now, simplify the bottom. 2 times 5 is 10 minus 3. Okay? Now, 45 minus 24 is 21, and 10 minus 3 is 7, and now that's an easy division. The answer is 3. Okay? Why don't you hit pause on the player, do C and D, and then come back and check to see if you got it correct. All right. Welcome back. I'm going to plug in 5 for x, so I get 5 squared minus 2 times 3 squared. My order of operations says I have to apply my exponents first, all right? So 5 squared is 25 minus 2, and then 3 squared is 9. Notice how the 2, because it's outside this parenthesis, is not getting the exponent. So 25 minus 18 is equal to 7. And that's your final answer. You were asked to, on D, you were asked to do this two different problems so that you could see the effect of parentheses. So my first one does not have parentheses, so I'm going to go 3 times 3 cubed. All right? I have to do my exponent first. 3 times 3 cubed is 27, and then 3 times 27 is 81. Now here, on this one, 3y, and that whole thing cubed, I do 3 times 3, and then I'm going to cube that. So my order of operations says I have to clean up my parenthesis first, right? So my parenthesis is 9 cubed, and 9 cubed is 81 times 9 is 729, and there's the answer. Okay, if you have any concerns over these, or you're not sure what I did, go back, listen to it again, and see if you can glean some more information. All right, part of your homework tonight, you're going to be translating words into algebraic expressions. This is where the rubber meets the road. These are the things that you need to build your critical thinking skills. So, keywords. Hold on one second. Keywords. These are the phrases that you see in wording, and these are the operations that you use when you see those words. Okay. So we have added to. 7 is added to a number. All right. That means you're going to add. That one is very intuitive. The sum of 3 plus a number. Again, that's addition. So that's intuitive. These are, you're going to apply the property of addition. Okay. If you see the word minus, we've used that word since elementary school. So minus means to subtract or put a minus in the order that you read the terms. 7 minus x would be 7 minus x. Okay? Difference of. the difference of 6 and 4. Okay, you minus them in the order that you read them. 6 minus 4. 6 minus 4. Okay? Less than. Less than is one I'm going to show you an example, and then subtracted from. These two, you subtract, you use a minus symbol, but you reverse the order of the terms as you read them. Okay? Product means multiplication. Multiply. Times means multiply. Divided by means divide. Quotient of means divide. Okay? So let's try our hand at some of these. The sum, okay, the sum of a number. All right, let's read this title up here because we're told what to use when we see the word and number. Okay? Writing words in mathematical sentences. Use the variable x to represent a number. Okay? So here's a number, so we're going to plug in x and 9. So this is x plus 9. Now, with addition, it doesn't matter the order that you put them. That's only with subtraction and division. All right? With addition, you don't have to worry about the order. 9 plus x is exactly the same thing as x plus 9. All right? 7 minus a number. Minus tells us to use subtraction, and we write the mathematical expression in the order that we read them. 7 minus x. Remember, a number is x. A number subtracted from 12. Well, this tells us to subtract, but now we have to reduce 12. We don't reduce the number, we have to reduce 12. So this is like a less than. You have to flip the order as you read them. This needs to be 12 minus x. 7 less than a number. This is like subtracted from. Less than, it's subtraction, but you want to flip the order that you read them. So it becomes x minus 7. 7 less than a number. You're going to reduce the number that you don't know by 7. Okay? Now, read this in comparison to 7 less a number. 7 less a number is, you go in the same order. It's 7 less, you're going to peel away a number from 7. So this is just as you read it, 7 minus x. So 7 minus a number and 7 less a number look exactly the same. Okay? It's that than that you got to be careful of, less than. Why don't you try these? These are products in division. Pay attention to the little question under F and hit the pause button, come back and see if you got them right. Alright, welcome back. The product means what? Multiply the product of 11 and a number, 11x. Remember that I can just butt those right up together, and that's standard procedure. Okay, that means 11 times x. 5 divided by a number. Divided by, you go in the order that you read them. 5 divided by a number. Okay, now be careful, when your variable is in the denominator, you have to put a constraint on that. X cannot equal 0. If x equals 0, this whole thing is undefined. G, the product of 2 and the difference between a number and 8. Okay, there's a lot going on here. We have the product of 2, product means multiply, 2 and what? The difference between a number and 8. Difference means I subtract in the order that I read them. a number and 8, x minus 8, and then I'm going to multiply that by 2, just like that. All right, these are the problems that we're going to be working on during class time. Please go over the notes again. Make sure you have that filled in so you have that resource. Make sure you bring your binder because you may need to peek back at the order of operations. Have a great evening, and I will see you tomorrow in class. Bye now.